Alright, time for another math easy solution. I'm going to discuss optimization problems basically. Well, in this example, look at maximizing area of a rectangle. Basically, optimization is problems are just basically maximizing or minimizing stuff like maximizing profits or minimizing losses or whatnot. In this case, we'll look at this example. Basically, a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river, and he needs no fence along the river because it's just a river there, and we have to know what the dimensions of the field that has the largest area. Basically, just to draw, first thing to do is draw this problem out just to get a better idea of what it is. So as you can see, there's a river here. The fencing here is a rectangle, so we want something like this, just three lengths. And in this case, these are the same. We could just call them X. This would be Y, and then the area is this area inside here. So basically, you could either have it short one, short X, really wide. You could have it really deep and whatnot. But you want to know the max area? Well, we're going to use calculus. First thing we got to do is write down the function of area. Area is just length times width of a rectangle, X times Y. But we're also given that we have 2,400 feet of fencing. So we're given 2,400 feet. Now this equals the length of this. This is just 2x plus y. And now, so now we have a function of a, which is a function of x and y, but then here we could rearrange this one so that we'll have y a function of x, and then this becomes a function of x only. Then we could use calculus to basically find out the max. So we just rearrange this one. Y is equal to 2,400 minus 2x, take it out. So now we just plug it in there. We're going to get a is equal to x 2,400 minus 2x. And we could just simplify this further. So a is a function of x, 2400x minus 2x squared. So now we have this. So now we could use calculus basically to get the critical points. If I showed my other video what critical points are. So the max has to either be at the, this is a continuous function, so the max, and the max has to occur at the critical points or the endpoints, because it's a continuous function, so you'll have something like this. It's going to be like this or something, so it has to be either here, or these, whatever these critical points are. If it's something like that, but also we have to look at this one here to see the endpoints. Well, the endpoints, this one, when we have x is equal to 0, or when we have basically no fencing on the sides, we're gonna get basically area 0. So that can't be it. And if we can't put x is well, x can't equal to 2,400 if you just make it straight line, because this would be negative here. So we have to find out when it's 0. So when ax is equal to 0, what is x? Well, we know this one's going to be 2,400 minus x of 2x. This, put the x here. So basically this is equal to 0 when x is equal to 0, and x is equal to, this one here is 1,200. Because we're gonna just 2,400. Let's rewrite it. 2,400 minus 2x. If you set it equal to 0, divide by 2, just rearrange it. You're gonna get this. And then if it's greater than 2,400, you're gonna actually have a negative number here. Because if it's greater, you're gonna be squaring it minus that. So basically, this one is only defined for x is greater than 0 and less than 12. Less than 1,200, and at both endpoints it's 0. So basically, a of 1,200 is 0, so it can't be at the endpoint, so it has to be at the critical point. And it has to be at the critical point, and we know the critical point is when the derivative is either 0 or not, doesn't exist, but in this case it is differentiable, so we just take the derivative, and the derivative is going to be a prime of x is equal to, well, derivative of 24x is just 2,400 minus, this one's going to be 4x. So when we set it to 0 equals to 0, we're going to get 2,400 minus 4x. Now divide this, just rearrange this, divide by 4, we're going to get x equals to 600 feet. And now this is our max. So this is our max, and we're going to get basically, well, we need to solve for y first. We plug in the equation for y, put x in here, we're going to get 1,200. This would just be 1,200. And our area is going to be A is equal to 1200 times it by 600, and this would just equal to 720. Yeah, this is feet, just put it there, and this is 720,000 feet squared, and this is our max here. So we could just write this down. Then we know the dimensions if you draw it out. There's a river, there's a straight river here. Now we're gonna have 600 feet, which is 1200. Yeah, this will be 1200 feet, and this is gonna be 600 feet. Now there's, yeah, and this is the max area. Yeah, well, that's all for it. You can download these notes on the info below. Basically, yeah, we're just using just simple local max and minimum. In this case, that's the absolute max. And yeah, just using calculus. You can download these notes, and yeah, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.